Alright, so what is an equation? That's a mathematical statement that two things are equal. So 3x plus 2 is equal to let's say 2x plus 5. 3 plus 5. So this is a linear equation. It says 3x plus 2 is the same value as 2x plus 5. So if you threw 3 x's and 2 pennies into some scale, and you threw 2 x's and 5 pennies onto the other side, they're equivalent in value. And they're linear because the highest degree exponent of these two expressions is a 1. There's a couple of things you're allowed to do in order to solve an equation. If an equation can be solved, you can add any value to both sides, or subtract. So let's subtract. We'll subtract 2 from both sides of the equation, and we get 3x is equal to 2x plus 3. Our ultimate goal is to find out what the value of x is. So, in other words, I just took 2 off of that scale, and then it became unbalanced. So what I had to do is to take off 2 on the other side. So now let's take 3 off, the 2x off of this side. So you take 2 x's out of that side of the scale. So now I have to do it over here, where they won't be balanced anymore. And I'm left with x is equal to 3. So I have x on one side of the scale and 3 pennies on the other side. So that tells me that x was 3 pennies all along. So equations can have different amount of answers. Sometimes linears actually have one solution because they have a first degree exponent. Quadratics can have 2. Cubics can have 3. Quartics can have 4. There are cases where they have no answers. Any of them can have less answers than their exponent. And sometimes they actually can have an infinite amount of answers. Let's look at an example where that occurs. If I told you that x was equal to x, if you ever get something like this, you'd want to say, hey, I want to get x by itself. Let me subtract x from both sides. I'll actually get 0 equals 0, and I don't know where to go from here. So whenever you get either of these two expressions when solving an equation, 0 equals 0 or x equals x, that means your equation actually has infinite answers. You can plug in any number for x. Let's say if I plug in 1,000, this side will be equal to 1,000. So it has infinite answers. Then there's the example that has no answer. Let's take a look at that real fast. We had 3x plus 2 is equal to 3x plus 3. Now looking at this, it should look really odd, and that is because how can 3 of this mystery object and 2 things be equal to 3 of this mystery object and 1 thing? And that's why it has no solution. If you try to solve this by subtracting the 3 x's from both sides, you will get something that makes no sense. You will get 2 equals 3. If you get something like this, that means your equation has no answer. Alright, so we've discussed equations with one answer, no answer, and infinite answers. Let's look at the things you're allowed to do to an equation. Starting with a solved equation, we can actually make it more complicated by showing what you're allowed to do. Say x equals 1. You can add any value to both sides. We can add either, let's do this, let's add 3x to both sides, and we'll get 4x is equal to 3x plus 1. Unlike terms can't be combined. We can subtract any value. We can subtract 6. Why not? So this is 4x. It's right in red. I want to make it as visible as possible. So we get 4x minus 6 is equal to 3x minus 5. You can factor anywhere if you'd like to. So here we can actually factor out a 2. So that's 2 times 2x minus 3 equals 3x minus 5. You can divide both sides by any amount. So we can divide both sides here by 2. And these 2's will cancel out, leaving us with 2x minus 3. Whoops. 2x minus 3 is equal to 3x minus 5 over 2. Did I leave anything out? you're allowed to multiply both sides by any amount you want. Let's multiply this and this by, I don't know, 8. And we'll wind up with 16x minus 24 is equal to 24x minus 40 over 2. We can simplify any expression in the process, so that would be 16x minus 24 is equal to 12x minus 20. So let's just solve this. We know the answer is 1, so let's just do that real fast. To do that, we want to get all the x's on one side and all the constants on the other. So we can, actually, there's one more thing we can do. We can distribute, which I guess we did over here. Alright, let's get x by itself. So we're going to add 24 to both sides, and we'll get 16x is equal to 12x plus 4. We can subtract the 12x from both sides. We'll get 4x is equal to 4. You're allowed to divide both sides by the same number, so let's do that. And we'll get x is equal to 1, which is what we said it was. If you actually substitute the value 1 into any of these equations, both sides will be equivalent in value. Alright, so let's take a look at an example. This came out of the New York State Algebra Regents exam, so let's actually work through this. I always like to distribute first, if you're comfortable working with fractions. So let's do that. I am very comfortable, so that's not a problem for me. So that's 3/5 x. If we multiply 3/5 by 2 while distributing, we'll get 6/5. This is still x minus 4. I'm going to put all the x's on the left side. So I'm going to subtract x from both sides. And since I can, at the same time, I'm also going to subtract the 6/5 from both sides to move all the constants onto this side, just to make this shorter. 3/5 x minus 5/5 x is negative 2/5 x. 6/5 minus 6/5 is nothing. X minus x is 0, and we have negative 4, which is negative 20/5. If we subtract, we'll get negative 26/5. Alright, what else can we do? At this point, I'm just going to rewrite it over here just for space purposes, not changing anything. This is one that most people don't know, or don't do, or have trouble with. We can multiply both fractions by 5. Try to use blue, it didn't want to go blue. There we go. Multiply both fractions by 5 to cancel out the denominators. Yeah, if I knew negative 2/5 of x, I'll now know what negative 2x's are. I want to keep that in red. So negative 2x is equal to negative 26. And I can divide both sides by negative 2. And we'll get x is equal to, again trying to stay in red, x is equal to 13. Another way we could have done this, let's go back here. Instead of dividing by 5, we can just multiply by the reciprocal fraction, and that'll cancel out both parts at the same time, so that's negative 5/2 and negative 5/2. That'll give us 10 over 10, which is 1, or just x. These cancel out, and these cancel out. This is negative, oh, the 5's cancel out, and this will divide and give us, well, that was a negative here, so this will be 13. Alright, so we got the same answer. So now to do a check, you should always check your you work, and you do that by substituting into the original equation. Some people are tempted to plug it in somewhere in the middle, like here, but if you made a mistake, you can't identify it. So you have to do it at the beginning. I did this video earlier today and screwed it up, so that's how I know you need to do a check. So the check, we know 3/5 times 13 plus 2 should be equal to 13 minus 4. Now I just did something that's a peeve of myself, so I'm going to fix that. If I'm making a substitution, I should use parentheses, just to make sure everything works out correctly. So 13 plus 2 is 15, times 3/5, which is equal to 9. 3/5 times 15 is 3 times 15 is 45, divided by 5 is 9, 9 equals 9. If both sides are equal, you found the correct value of your variable. So 9 equals 9 says it was correct, so x equals 13. Let's look at a rational. So this one's a little unusual because it has fractions all over the place. First thing I would recommend is we make all the fractions the same, all the denominators the same. So this has a denominator of 1. We can make them all have a denominator of 3x pretty easily. That's 6 over 3x. If we multiply the numerator and denominator of the middle fraction by 3x, we get negative 9 over 3x, and that would become 78 over 3x. So, knowing this, we can just get rid of all the denominators. So now we have 6 minus 9 is equal to 78. Oh wait, it's 9x, excuse me, 9x. Okay, and the reason you can get rid of all the denominators is I know that if I divide everything here by 3x's, these things are equal, the numerators are equal. I mean, if with the denominators the numerators are equal, then without the denominators the numerators are equal. So, solving this equation is pretty straightforward. Subtract 6 from both sides. Negative 9x is equal to 72. Divide both sides by negative 9. And we get x is equal to negative 8. We can check our answer by substituting into the original problem. 6 over 3 times negative 8 should be equal, minus 3 should be equal to 26 over negative 8. This is equal to 1 over negative 4. It's 6 over negative 24, which is 1/4. Minus 12 fourths should be equal to negative 13 fourths. Combine these terms, we get negative 13 fourths is equal to negative 13 fourths. Okay, and that covers solving linear equations as a refresher course and solving rational equations as a refresher course. If you have the same denominators, you can just get rid of all the denominators. This is the big tip for solving rational equations.